Welcome to the DemandML application demo. This DemandML solution lets you visualize the data decomposition over the time period, and the seasonality of the data. Post-data transformation, the model is trained for a given dataset to deliver the predictions. To access the DemandML solution, first go to the marketplace via Google Cloud Platform. In the marketplace, search for DemandML. This brings you to DemandML homepage, which contains detailed information about the application. To deploy the solution, you first need to enable a few APIs on the Cloud Console. A list of those APIs is given in the Getting Started document. To enable these APIs, go to APIs and Services section in Google Cloud Console. Search for the listed APIs and enable them. First, go to Compute Engine API and enable it. Now enable the Cloud Storage API. Next is Cloud SQL API. Then enable Cloud SQL Admin API. Next is AI Platform Training and Prediction API. After that, enable Google Cloud Storage JSON API. After all the required APIs are enabled, go back to the solution homepage and click on Launch on Compute Engine. Here you can see the basic details like the zone where you want to set up this VM instance. In machine type, you can customize the number of CPUs and memory. It comes with basic configurations of 2 CPUs with 7.5 gigabytes. Check Allow HTTP traffic from the internet, since it will be a web application. Finally, click on the Deploy button. Now using the Deployment Manager configuration, it will read all the necessary cloud services and will install all those services. Here on the left side, you can see the progress of the setups. We will have to wait for 3 minutes or less. Once the setups are deployed, go to VM Instances page from Google Cloud Console. Here we can see the deployed VMs with their respective external IPs, which need to be converted to static IPs. Go to VPC Network and select External IP Addresses. For the deployed VM, select Static and click on Reserve. Post this conversion, go to Cloud SQL. We can see that the database is still updating. In order to allow traffic from the Compute Engine to Cloud SQL, we need to add the Compute Engine's external IP address to the DemandML Cloud SQL Instance Network. To do that, go to Cloud SQL ML Instance. Go to Connections. In Connections, we need to add a network. This network is the source where we want to allow the traffic to come in from. In our case, it will be the Compute Engine. Add the external IP of the Compute Engine VM instance and click on Save. Once this configuration is saved, go back to the Compute Engine. Here you can see the latest VM instance deployed by DemandML deployment. Click SSH in that VM. Once the deployment is ready, you can see the application running. In order to log into the application, we need to follow a few more steps. So go back to VM SSH. In Cloud SQL, we added the external IP of the VM instance so that it can identify the VM and allow traffic in the Cloud SQL. Now we need to add Cloud SQL external IP address to this VM so that it can create connections and access the database. In order to do that, we need Cloud SQL's public ID address. Copy this public ID address of the Cloud SQL instance and run the command update env.sh space public ID address of Cloud SQL instance and press Enter. This will add this external IP address to the environment variables set up the database and create the tables. Now go to the Connections page of Cloud SQL Instance and add DML Web Network and click on Save. Wait till the instance has the public IP of the VM instance. After it is updated, we can run the configuration. Run the same command again. This command creates tables in the Cloud SQL instance along with default user record where the user is admin and the password is also admin. To verify login credentials, go to the compute engine. Click on the external IP of VM instance and enter the default username and password. We can see that the database is successfully set up. Now, in order to create model training and model prediction, we need to access cloud storage from the compute engine, for which we create a service account with two necessary roles. One is a cloud storage admin role, and the other is AI platform admin role. To do that, go to IAM and admin. Click on Service Accounts. Click Create Service Accounts. Select Name for the service account, DML-Web-Cloud-Access. This service account is for us to access cloud storage APIs and AI platform APIs. Click on Create. Now add the roles Compute Storage Admins and ML Engine Developer. Click Continue. Finally, we need to create a JSON key for this service account. Click on Create Key, select JSON Radio button and click on Create. This service account key is now downloaded, which needs to be uploaded to Compute Engine VM instance. Go back to the VM instance. Upload the downloaded JSON key. Copy the absolute path of this JSON key. This absolute path needs to be set as the default Google Cloud credentials to access cloud storage and AI platform. To set this environment variable, we need to run update Google cred env.sh space absolute file path of the JSON key. Click Enter. After this step is completed, we can start using the application. Go back to the application and log in with the default credentials. Click on Upload Dataset. We will be uploading a sample dataset to test the solution, which you can find in the storage bucket. Choose the dataset and download it. Go back to the Upload Dataset section. Give this dataset a name and upload the file. Click on Submit. Once the upload is successful, it will be redirected to the dataset homepage. Here you can see the sample dataset and dataset summary. Once the dataset is uploaded, we can go ahead with data transformation. Create a data experiment. Fill out all the required fields and click on the Create button. Once the experiment is complete, you can see the distribution of datasets over the time period and the seasonality decomposition of the dataset. Experiment and choose the recently completed data experiment. Choose Custom ML Model and click on Create. There are multiple stages in a given ML experiment. Once it's created, the status shows Created. Post which, we will create the model training and the status will be updated to Queued. Once the model training running on AI platform is completed, the status will be updated to Trained. After training, we run the predictions using the same dataset we use for the data experiment. For ML experiments, we split the data into two segments, one as training the data for training the model, and the other as prediction data used for predictions. Once the training and predictions are complete, you can see the status being updated to Prediction Generated. To see the output of this ML experiment, click on this ML experiment. The predictions here contain order dates, actual, and forecast values. On the left side, you can see the basic details of the ML experiment. It is time to train the models and timestamps. The right side contains the prediction data. You can easily export this in a CSV file from here and get clear understanding of the actual and forecasted demand for each order date under observation. Under the Visualization tab, you can observe the graphical representation of the actual and predicted values. This completes our demo for the Demand ML solution.